Hello, everyone. My name is Siddhant, and thank you so much for joining in for this session. Good morning, good afternoon, good evening, based on the time zone that you're joining in. I'm super excited to speak to you, all of you, today at Google Cloud Community Days Mysuru 2023. Before I begin on the actual topic, I would like to talk a little bit about myself. As you know, my name is Siddhant, but you can call me Sid. I work as developer relations lead for APAC at Neo4j. I'm currently living in Bangalore, but I'm hailing from Delhi. That's my hometown. I previously worked with Google, IBM, and two other startups, and brings along with me more than a decade of experience in community building. Now, that's a QR code for my Twitter handle if you wish to get connected with me in the future. All right. Okay, so moving on, and before I begin on the actual topic, I would also like to call out the communities and programs that have been an integral part of my life, my personal life, my professional career, starting with Google Student Ambassador Program, which gave me the kickstart to my community journey, followed by GTG New Delhi and then Headstart Network Foundation. It's a volunteer-driven organization that helps early-stage startups and aspiring entrepreneurs. I was also recognized by Intel as Intel's software innovator and by ACM, Association for Computing Machinery, as ACM Distinguished Speaker. I lead the foundation for GTG Cloud New Delhi way back in 2018, and currently I'm a mentor and facilitator for Google for Startups Accelerator program and leading GTG Cloud Bangalore community. Well, that's a lot, so let's move on. Okay, I'm not here to just deliver my session and go away. If you're listening to my session, I have an exciting opportunity for you to win this cool Neo4j t-shirt and an ebook. But to win this, you have to do a task. And what's that? Let's look at it. You have to make a Twitter post about how excited are you for this session. I'm super excited, but I'm looking forward to your excitedness as well. So make sure you tag me. That's my Twitter handle at the rate SidAgarwal04 and of course Neo4j. And make sure you use the hashtag graphs are everywhere. All these three things are mandatory to be eligible. And I'm going to give away one winner who makes the most creative post. All right. With this, let's get started with the topic. So I'm guessing you would have got to know that, okay, I'm going to talk about graphs. Neo4j is a graph company. The idea about a graph database was conceived on a flight to Mumbai. That's one interesting fact about Neo4j. In fact, the first code was written in IIT Mumbai, uh, IIT Bombay, when a co-founder and CEO, Emil, was traveling to IIT Bombay for a research project. Well, Neo4j is a Swedish company at heart, based out of Silicon Valley, and we started in 2007, where we first started as an open source edition, and then start converted ourselves to an open core model where we're still having retaining the community edition, but we also have the enterprise edition. We launched the Neo4j 5, the version 5, that was released last year in November 2022. Well, of course, Neo4j has been the pioneer of the graph database technology in the market, and we continue to be the leading provider for graph technology solutions to the world. On DB engines, we are ranked number one in the graph database category, as well as we're considered as one of the top databases in the world. But that's not all. Today, I would want you to take a look at graphs in general. Try to understand what graphs are. Why are graphs really cool? Why are they basically a really great representation of the real world? Where can we use graphs? What are scenarios or use cases for using graphs? Looking a little bit at the property graph model and a quick introduction to Cypher, which is a query language. And then what we or you actually would want to do is to go to get a hands-on. Yes, all of you can code along with me here because we can use Neo4j or RDB free, for which I'll show you the steps to set up an account in some time. And I thought to make this session a little bit fun and interesting, so we'll take a look at some of the movies data to see what we can do, something which I guess everyone loves watching. And then I'll show you where you can continue your graph journey and as such. Okay, hold on. So you would have tons of questions around graphs, graph databases. I'm going to decipher all of them for you, but what's a graph? That's the first thing that we want to understand. So what's a graph? Is it the thing on the left or is it the thing on the right? Left, right, confused? Okay, so what I mean to say is the one that you see is the networks, the connections. Is that the graph, or the one that you see that on a graph paper, some lines, some draws, some lines and charts being drawn? So actually what we call graphs, like from the graph database industry, is a thing on the left. It's the network of connected entities or connected nodes. And on the right side, oftentimes people call this as a graph. We prefer to say this like diagram or chart to make it the clear distinction. So for us, a graph and a network are what we are talking about versus diagrams and charts over here. All right. Well, this isn't a graph. It's actually a chart that shows how people adapt to graph thinking over time. So once you go over graph, you'll see that you're never going to go back. You'll start falling in love. Let me show you as well. Okay. If you're wondering that graphs are pretty new, this is something which has been launched recently. Well, you're wrong. The graph theory was something which was launched 300 years ago when this person named Leonard Euler, who laid the foundations for graph theory. And that's how the graphs have been there in the existence. Now, first of all, what is a graph? A graph is a collection of objects, each of which has a set of binary links with the other objects. Now, graphs are a useful way to model data for the purposes of mathematical analysis. And they have been around for quite a long time, as I said. The first use of graphs was by this person, Leonard Euler, in 1735. And there's a very interesting story behind it. He used the graph theory to prove the famous seven bridges of Königsberg problem that had no solution. Okay, let's understand what was this problem all about. So what is the seven bridges problem? Königsberg, Prussia, which is now Kaliningrad, Russia, is a city spanning Perigal River. Okay, it includes two large islands, as you can see over here in this particular image, which are connected to one another and to the river banks by seven bridges. There are the seven bridges, and a map of this arrangement is what you are seeing on the left hand side, right? And the seven bridges problem says that is there any possible route through the city that crosses every bridge exactly once? Now, some pen and paper experimentation will quickly suggest that there is no such route. However, proving that there is no solution is much more difficult. But Euler invented graph theory as a tool to aid this proof. The graph representation of the problem is on the right. That what you're seeing over here, that four land masses, each representing by a node, and seven bridges, each representing by a relationship. Now, what did Euler observe? The route taken within each landmass is irrelevant. Only the sequence of bridges being crossed matters. Now, whenever you enter a landmass via a bridge, you must leave it by a different bridge, except at the start where you leave but do not enter, and at the end where you enter but do not leave. Okay. Also, ergo for the problem to be solved, every landmass except the start and the end must be touched by an even number of bridges. Now, based on the above observations, the problem has no solutions because, as you can see as well, all the four land masses are touched by an odd number of bridges. And that's what laid the foundations of graph theory. Okay. Now, what are graphs in general? So actually everything that you can connect is a graph. So I always say that there is no such thing as disconnected pieces of information in the world, right? Or disconnected pieces, right? So there are people who have connections, historical events, which kind of have reasons why they happen, but they also have like outcomes. There's things like proteins in biology, for instance. There are things like markets, economic markets, especially today we see that a lot. Like there are so many dependencies of markets. If someone cuts someone else's off a market, then they have a lot of problems, right? And not just directly, but also transitively. So not just the organization that cuts off from the market, but also their dependents, right? So things like network dependencies in the software. For instance, what about my libraries and the libraries and transitive dependencies? What about security there, right? So what happens if one of these libraries that I'm not directly depending on, but I'm depending on like three steps later has removed a security issue? I'm still affected by that because I transitively use this library. So there's a lot of things that you can consider over here. So here, for instance, water is a very simple molecule, but you, of course, know proteins and DNA and all kinds of organic molecules are complex networks. And then it's not just a body primary structure. but also a secondary and tertiary structures. For instance, for protein folding, that can also be represented as graphs as well. And so transport networks. There's like information networks, there's even like data centers and all cabling routers, switches, and so on. So basically, the means are endless. Whenever you're basically drawing something on a whiteboard with arrows and circles, that may be represented as graphs. So I think graphs are everywhere. In this image, we have got what, circles and some arrows, right? Arrows connecting them and connecting some circles. This is precisely the structure of a graph is. Now you've been seeing real world use cases of graphs in a daily life, just that you've never bothered to go in depth about it, or rather, you never got the realization. Yes, these are the examples of graphs. For example, the image that you're seeing over here is a Delhi Metro map. Of course, I'm from Delhi, and I'm going to talk about Delhi Metro, but not too much. So now, if I have to take a metro from the airport, which is that yellow line down corner, down at the bottom, uh, to my home, which is on a red line, somewhere near Dilshad Garden, Shadra. Now, there would be n number of ways to go about it. I can go all over Delhi and then reach my location, but I will always look for which is the shortest path to my home. The one in which I have to change less number of times, or maybe which has less number of stops as well. Now, that shortest path finding is an example of graphs. Just that in actual scenarios, the scale will be like 100x or even 1000x, or you can even think of beyond it for this kind of problems, right? So this is where graph databases come into picture, where graph databases keep the data in its natural and connected state. So you must have heard about relational databases, which are structured, schema-based, storage and retrieval. They used to run on SQL, structured query language, and then came in NoSQL databases where the scale out was much faster. There was simple model for storage and retrieval, and you felt that okay, that's the new thing out there. But I'll say almost a decade ago came graph databases, where can natively store and query relationships, which is much more flexible, helps in scaling out on storage and retrieval, and also analytics as well. Uh, more about this in the upcoming slides. Okay, so what Neo4j has to offer in the graph database industry? Well, Neo4j is an integral platform that can process real-time transactions and deliver real-time analytics to applications, APIs, business intelligence tools. Now, analysts and data scientists can perform ad hoc investigations and predictive analytics directly with the platform using our Neo4j Cypher browser and Graph Data Science module. So as you can see over here, we didn't restrict ourselves to just building a graph database, but we've built an entire ecosystem for everyone to explore, to use, all the way from querying to visualization to using it for machine learning. We have everything under one roof for you. Okay, let's talk about what is graph database. Now, as you said, two circles joined by an arrow, that's the structure of your graph. Now, what are these two circles? These two circles are basically your nodes or vertices. These are commonly represent they commonly represent your objects, your entities, or merely things. So in your seven bridges problem that we discussed earlier, the nodes were kind of your land masses. Another example that everyone that can relate to this concept is your social graph. So people interact with each other and form relationships of varying strengths, right? Now, nodes become useful because they hold data in the form of properties and they have label to define an optional schema. They are basically a nouns. So in your query, let's say if I have a movie database, which we'll discuss later, and I want to query that database and okay, which actors play in this movie? So actors and movie are your nouns, and that becomes your nodes as well. How many movies this director direct? So movies and director are your nouns and should be your nodes as well. Now these nodes have some properties like they are the unique identifier. They helps in anchoring a query, like starting a query, or with navigation with filtering, and also for projecting an output. Now, what connect these nodes is called relationships, also known as edges. They also hold data in the form of properties. They have types to define an optional schema. They connect nodes explicitly, and they allow for direction. So Unlike nodes, which are nouns, so relationships are typically verbs. So we could use a relationship to represent a personal or professional connection. For example, person knows person, person married to another person. To state a fact, like person lives in location, person owns a car, person rated a movie, or even to represent a hierarchy like parent of child, software depends on library, so on and so forth. Let's take an example. So over here, these as we know that graph essentially consists of nodes, and these nodes represent things. They represent entities. So in this example, we're talking about a entity or a node, which is MacBook. It could be a product, it could be a car, it could be a location, it could something physical that you can say. So you can identify these nodes with one or more labels, right? So these, as I said, nodes represent things identified as labels. So we have added a label over here is product. So we can assign a label to essentially group a node, and this allows us to retrieve this later on. And there can be one or more labels. It's not just that only one label is allowed for one particular node. Now, so in this example, we have a product, but is also marked as fragile. So there are two labels added. We can assign properties to nodes in key value pairs. So in this case, we can see that we have a name property. So it's a MacBook Pro, and then we have the price, which is 2699. I'm guessing it's dollars, right? So they have a key value pair as well. Okay, we have added another node over here. That's a customer labeled node, which has a key value pair as said with my email ID. So we use relationship to connect these nodes together. So the lines between the two circles, we call this a relationship. A single relationship will connect two nodes, okay, which of course will have a type as well. Just the way we had it labels for our nodes, our relationship has a type. So these have a direction, although you can ignore this direction and query in either direction at the query time. We can also assign properties to the relationships, just the way we did it for our nodes. So here, rated is the relationship type, and we had the properties, which is stars and created ad. Um, so in this, so the context that we have over here is that properties is that the customer with the name of Sid has rated a MacBook Pro 3 stars. Uh, Maybe you must not be that happy the quality of the product there, right? Okay, so that's about the nodes and relationships, which forms the, I'll say, the fundamentals of a graph database. And then comes the Cipher crash course. Now, what is Cipher? The way we query the structure of known term relationships is with a language called Cipher. This is something which has been designed, developed by Neo4j, and it's also contributing to GQL, which is Graph Query Language. It's one of the first standard language to query a graph database. Just like structured query language has become more like a standard, graph query language is going to become a standard in some time in future, where all the graph databases will have one specific language, and Cipher is contributing to GQL. So what is Cipher? Cipher is a declarative query language that allows you to identify patterns in your data. So in this case, it could be find the customer or customers who has rated a product with 3 stars or less. Uh, and we do that by drawing the patterns on screen using an SKY art style syntax, like your dashes, your brackets, your arrows. Those are the things that we use. So for example, here we have two nodes, the ones that we were discussing. We use the rounded brackets to kind of draw this circle. So the circles are replaced with two rounded brackets. And then we can use the colon to define the information that we are interested in that pattern of that in that pattern for that nodes. So in this case, we're defining the labels over here, which is customer label and product label, right? So we have the customer on the left and the product on the right. Now, in order to draw the relationships, we use dashes. So we specify that with two dashes that you are seeing over here, and one next to customer and one just before product. Now, then we can use a greater than or a less than arrow to basically denote the direction of the relationship. So in this case, the relationship is going from customer to the product. So that's why you see a greater than arrow towards product. Okay. Next, we use square brackets to draw a box around the relationship. And then we again similar way, just like we did it with nodes, we use colons to specify the information about the relationship. In this case, the relationship type with a colon. And then with all of these patterns, what we can do is we can assign a variable to each one of these elements, nodes and relationships, so that we can process them and we can pull information from them in the future. Okay. Now, the way we read from a database using Cypher is using what's called the match clause. So in this case, we have used the match clause at the start, and then we define a pattern. So we are defining a pattern, or what's sent to the database is find me a node with a label of customer and give that an alias or a variable C. And then we want an outgoing relationship to a product, right? And then once we have that pattern has been found in the database, we can use the return clause to return information about those nodes. As we want customer name there, we're giving an alias of customer. We want the name property of the product. In this case, we are calling it the product. And then we are taking the stars property from the rated relationship, so R, and given that an alias of rating. Sounds good? I'm guessing that everyone is able to follow me. Okay. So the way this works is when we define this pattern and we call the match clause. What Neo4j will do is it will analyze this query and it will kind of work out on a starting point and some anchor nodes to start this query. In this case, depending on the shape of the graph, the database statistics will determine the query that the query will start at this customer node. This is another example that I'm taking over here. Now, it finds a set of start node or anchor node, which is your customer, right? Where customer c.customer ID is Anton. Then from that node, the relationships are expanded by direction and the type until the entire pattern is satisfied. So we are saying, okay, we want to say customer is, we found, okay, the first one is match C customer, where very close was C customer ID was Anton, and then we are saying that, okay, this person is purchased. Okay. And in this case, we have got a constraint on the customer ID property. So we are looking for that node. If we kind of go away, check the index to find a node which has a customer ID of Anton. So now this is where the benefit of graph database comes in. Once we have these start nodes and these anchor nodes, we can then expand or traverse out through the relationships by type and direction until we fulfill that pattern. So right now we are expanding out through all the purchase relationships for that customer until we get to the node on the other end, which is the order. Okay, we're saying purchase, which is an order. The next node is the order node. Okay, and then we check the label of on that node to make sure that the node has a label of order, which we did, and then expanded out through the order relationships and the outgoing direction from that order node to another node, which is orders to product. So over here, both of them are orders to product. So we give that a variable p, and then we check out that that's got a product label out there. And then we're saying that the product should be part of some category. Okay. Then we expand out through the part of relationship to find the category. In this case, it's CC. CC has been given another variable, and we think has a child. Okay. And the one really nice thing that we can do with the graph database is that we can really specify the link paths. So we have a hierarchy of categories over here. The electronics category, which has a child category of computer, that has two subsequent child categories of laptops and accessories. And then what we say inside this pattern is from that CC node, that the original category node travels out from 0 to 3 degrees until we find a category with the name property, which is electronics, right? The category name is electronics. And then we return everything from everything that we have given an alias in that, right? That's a return star, right? I'm hoping that everyone is getting to the point. We wanted to get all the child categories over here and then return back everything. Okay, so that's reading from the database where we use the match clause. If we want to write the database, we have a few options. So we can use the create keywords to create a pattern in the graph. or we can use the merge pattern to try attempt to find or create a pattern inside the graph. We can have when we have nodes and relationships that we have found in the database, you can use the set property to either add a new label to a node or to set a property on a node or relationship. And we can use the remove keyword to remove the either label, and they will kind of from the node or a property from the node or relationship, they'll remove that particular label. And we want to delete an element from the graph, either a node or a relationship, we can match the pattern, and then we can use a delete keyword to delete that particular value. I'm not going to cover all of those in today's talk, but you can check out our quick reference guide for Cypher for more details. Just go to dev.neo4j.com/refcard. That's the URL which is already mentioned in the slide. So just go to this URL, and this gives us Cypher's reference card as per the current Neo4j edition that you can check it out yourself. Okay, so that's about using Neo4j and Cypher. The fundamental structure of a graph has applications far beyond mathematics that we were discussing. In fact, you may have seen the phrase graphs are everywhere across neo4j.com, or if you might see it on the website as well. Neo4j employees code graphs are everywhere a lot. It is our hope that you will see the connection between things everywhere in some time. Now let's look at some examples of graphs which makes them more amazing. This is why graph databases have been the fastest growing in the overall database market for the last decade. Organizations are discovering the many ways they can use graphs to help them understand their data better, provide more performant database applications, easier for developers to learn, adopt, and build applications. In fact, Neo4j was the first company to pioneer the graph database, and as the pioneer in this category, we are very proud of the fact that we had over 100 million Neo4j downloads, as well as have an enthusiastic community of developers and data scientists, which is now numbering over 250,000 plus members. Okay. Well, yes, by 2025, Gartner says that graph technologies will be used in 80% of data and analytics innovations, which is up from 10% in 2021. So I'm talking about just another 2 years. Just wait and watch for another 2 to 3 years, and you're going to see the penetration of graph technologies in every single field. But graphs has more to do with the transformative effect than being just a growing database market. With applications in space travel, in airline travel, or fraud detection, fraud prevention, personalized health, movie recommendations like large streaming players like your Netflix, security like your large web app companies using Neo4j to securely manage subscription permissions, COVID vaccine logistics. As I said earlier, graphs are not new. You may not realize it, but if you are banking or browsing a shopping website or booking a flight ticket, you may be interacting with a graph database. We at Neo4j are seeing dramatic growth in the adoption of graph technology now. To quote some examples, ICIJ, International Consortium of Investigative Journalists, use Neo4j and graph databases in 2016 when they launched the Panama Papers and exposed the rogue offshore financial industry. This is the graph data model from the Panama Papers. And not just in 2016, but they replicated the same thing in 2017 as well. This is 6 years old. Then they replicated the same thing in 2017 with Paradise Papers. Then they replicated the same thing again with Pandora Papers in 2021. I'm sure you would have heard these names in the past. This COVID graph project is another exciting use case where this organization created a COVID-19 knowledge graph. This is their graph data model. Okay, so those are the examples which I'm sure would have made you feel that, oh yes, graphs are exciting and amazing. But what is a graph problem? Like, how do I identify whether it's a graph problem? How do I get started with graph apps? How do I know that whether I should solve this problem with the graph or not? So a bunch of good graph use cases and scenarios is what we're going to discuss. But there are many more. And also, if you go to neo4j.com/use-cases, there are many more listed in detail with example data sets, white papers, and more detailed customers and so on. So if you want to learn more in detail about these, just go to neo4j.com/use-cases, and then you will see those. So basically, what I want to ask myself, that should I use a graph database or should I not use a graph database? Of course, I can represent this thing with connected information also with some other database, like within relational databases and join tables, or with a document database and basically use array of IDs that point to another document, for instance, right? Blah blah blah. There are a lot of things that you can do. But the question is this kind of relationship that's kind of treated like a stepchild in my in many other databases, in a graph database, that's kind of first class citizen. So whenever these relationships, this context or this topology of my entities is as important as the entities themselves, and I want to use them for kind of like get the analysis, like so that I can analyze my data or to work with my data or to infer more insights from my data, then considering a graph database makes a lot more sense, right? So if those relationships are more than just a foreign key that I don't really care about as such, but it's really the relationships between entities are important in my domain, then I think personally in most domains, actually the connections of entities are way more important than people, interestingly. Right. So that's where we use graph databases a lot. Something else that's interesting is all kind of hierarchies. So you have hierarchies in like product hierarchies, you have sales and purchase hierarchies, you have buildings. If you want to represent a building or a complex piece of machinery like an airplane, but typical things are like your HR and management hierarchies or sales hierarchies, where you then want to manage referrals or things like that, blah blah blah. So whenever you have like this kind of hierarchy of things, that something is under root and then goes down. Sorry, then a graph is really good fit as well. If you go like a bills of materials bomb model, then you have like the airplane and then all the parts, and then parts consist of parts, and then it consists of parts, and then so on. So if you look at a modern CPU, for instance, right, you have like substructures, then other cases like your geography, for instance. So another example is for instance, it's like your source code and abstract syntax trace, where basically you can say, okay, my program or my project is actually the root of the project, and I have classes or files, and then within the files, I have methods or fields. They use other pieces of my program, and so on and so forth, right? And again, routing that we discussed at the start. So this is basically a British road network or a train network. Basically, they can say that can I do a multimodal transport like between a car, bike, public transport, and so on, and walking. Can I get from A to B? What's the shortest path? What's the best? What's the most unique road? Helping me to find that. So first representing all of that as a complex knowledge graph, more or less. But then you also have like people finding these routes and being more dynamic and more having more information on the relationships that tell you, okay, is this like an easy route? Is this kind of an accessible to people with disabilities? Is this something where I can have a good view? Or is it just something that's through a really bad part of town where it's always kind of I'm stuck in rush hour or something like that, right? And then graphs can help you represent this in the first place, but then the second also is to create a routing information on top of that, right? And that's everything from personal travel to logistics to ships to shipping fleets and other things as well. So these were some examples. As I said, there are many more. Okay, so let's not bore you much with the information, but right, we'll now move on to the hands-on part. But just quick overview on the Neo4j Aura family. So Neo4j Aura is nothing but Neo4j as a service. It's a fully managed cloud service platform from Neo4j where we have two offerings. One is a graph database, another one is a graph data science product. Now within Neo4j Aura DB, the database, graph database, we have three editions. One is your Aura DB free for small product developments, your learning, your experimentation, your prototyping, and so on and so forth. For Aura DB Professional, it's basically for your medium scale applications in advanced development or production environments. Your RDB Enterprise is basically for your large scale mission critical applications that require advanced security and 24 by 7 support. Now, with Aura DS, which is a graph data science, we have Aura DS Professional, which is the fastest way to take your graph data science experiments to production with monthly billing. Then we have Aura DS Enterprise, which offers additional scale, security, premium support, and negotiable contract. So all those are things. But that's not all. We have a self-managed and self-hosted version as well that you can download, use it on-prem for both graph database and graph data science. We are here at Google Cloud Community today. Of course, why won't we love Google Cloud Platform, right? So Neo4j loves GCP. In fact, we are the only graph database on Google Cloud that's providing the Google Cloud providers, the Google Cloud users of an option to use a graph database. Well, Neo4j is complementing and not replacing any other GCP services. Usually, we get 1.5 to 2x of pull through consumption from BigQuery and infrastructure consumption, and more, in fact, if we use Vertex AI and if the Vertex AI is being involved. How to use it? Pretty simple. Just go to Google Cloud Platform, go to the marketplaces, just drop it down, and you will find Neo4j Aura over there. And then you can just click on it, manage it, and then just start using it directly on Neo4j. Okay, it's showtime. Let's go on to our Aura. So we'll log in and create a database so that we can together have the database ready. It will take a little time, 2 or 3 minutes to start the database. And so from that perspective, we can start now. We are running out of time. So all you have to do is go to neo4j.com/aura or just use any of these URLs over here. Let me just do this as well. neo4j.com/aura. Okay. Started free. Sorry, my bad. Then once you are there, you will land up on this page where you have to just click on, make sure, so you'll not find this. I'll just remove this. This is a previously created one. So for me, I can see Aura DB and Aura DS. I can create a free instance for Aura DS because that's open for Neo4j employees. Okay, so winner instances. So you land up on this page. You have to just click on this new instance. Then you have an option to either start with just a regular database. This is for new users. There are preloaded data sets as well. There's professional edition, as I discussed. Uh, as I said, we're going to use the movies database because we are all excited about movies and actors. Make sure you download this file. Just keep this password safe and handy because you're going to need this. Don't forget to lose this. So download this, keep it safe because you will be needing that in a while as I continue. Okay, it will take a bit of time, not too much, 1 or 2 minutes to create an instance. Where it is hosted, you don't have to worry, it's self-hosted. But yes, as I said, you have an option to go to your cloud console and launch a Neo4j Aura from there. So right now, what I'm showing you is how you can go it. So assume that this is your cloud console. When you see this 3 bars, you can go over here, click on this more products and just scroll down and you will find Neo4j Aura over here. You can also search Neo4j Aura directly over here too on your Google Cloud platform. Just open it. And then you get an option to manage on provider or enable the API. I've already enabled the API. That's why I don't have an option to enable the API. Just click on this manage on provider. It will open up on your 4J website where you don't have to worry about it. The information is pre-logged in, so you will automatically get billed. versus what I'm showing you now, the Aura DB edition. It's free for lifetime, so you won't be getting billed. But of course, there's a limitation on number of nodes and relationships that you can create via this particular Neo4j Aura DB instance. Okay, so let's see. Let's wait while it's being created. Okay, I think I forgot to. Okay, I have the password with me. So if you click on, just showing you meanwhile how it works on managing this on the provider. You click on this, you get this option, console.neo4j.io. You have an option to just log in. And similar thing, same thing, what you're seeing, you will be logged in via your Google Cloud project. Okay, let's see if an instance has been created. Okay, it has not. Why it's being delayed? This shouldn't take much time. Okay, meanwhile, let's go back to our deck. Okay, I think it is created and it's restoring. Okay, while it does, let's go back to our deck and see what's next. Okay, so this is what we said. What I said, go to new instance, click on it, and then start your first instance, create a first instance, either by loading your own data set or by an empty instance or by using a preloaded data set. This is how it works, and then you have to click on explore, where you'll open up your, you can have an option to rename your instance, and then you open up your instance. This is how it opens up. Let me see if, okay, yes, it is live and running. So you get 20,000 nodes. Oops, 1 second, let me just go back. So you get 20,000 nodes, sorry, 200,000 nodes and 400,000 relationships. Now, since we use a movies dataset, which is already preloaded, some data is already available. So we have 171 nodes, which is already available, and we have 253 relationships. And we have a luxury to add in more nodes and relationships until we exhaust our limit. Okay. Here you have to add in your password, which you should have saved. Let me add in the password over here. Okay, I am at this step where I need to add the password and just click on connect. That's it. As simple as that. Okay, once you log in, I think this is already taking some previous information. Once you log in, you get a detailed guide on the right hand side where you can see what is Cypher and how to navigate through this particular guide. Then on the left hand side, you can see the database information where there are 171 nodes. There are two node labels. One is movie and one is person. There are relationships, 253 of them. And we have 1, 2, 3, 4, 5, 6 relationship types. We also have property keys. The values is something that we can assign or they are pre-assigned automatically, which helps them connect with the nodes, right? So we have 3, 3, 6, and 2, 8 property keys: born, name, reading, release, roles, summary, tagline, title. Now over here, if you notice the nodes, the person node doesn't have something as like actor or director or producer separately. We have created one single node as person's node so that it can be combined together under one based on the relationship type as directed or produced or reviewed or follows or wrote or acted in. You can easily say that, okay, this is an actor, this is a producer, this is a director, this is a writer, and so on and so forth. Okay. Now, over here, the on the right, which I said, this is the browser rendered guide, which you can see and study whatever I discussed in the session already. This is what you can already see it over here. Cypher is a graph query language that is used to query the Neo4j database, blah, blah, blah. All the information. This is a Cypher query. You can just execute this in the query tab. This is your query tab. You can either copy paste this entire thing, copy it over here, and click here. This is the result that you get. Um, you have an option to directly run it over there too. So if you click on this, you can see the visualizations. Okay, this is the proper visualization for this particular one, where this movie has two other nodes connected, Tom Hanks and Robert is what I'm guessing, who directed, and Tom Hanks acted in the Polar Express. The query was basically to return all the movies that were released after the year 2000, limiting the result to just 5 items. So movie was a node, then it was released before 2000, and then we are returning the number and then limiting the results to just 5. Pretty simple ASCII format. Then we can run the next query directly clicking it over here, and it runs the next query where you want to retrieve all the movies released after the year 2005. Then this is to return the count of movies released after the year 2005. So it's a good exercise just to learn more about Neo4j, how the queries work, nodes and relationships. You'll get all the information. Just run the queries. You'll understand a lot. Labels, what are labels? What are properties? Then how to create a node. So we discussed about match clause, but then create clause is something which we never discussed, or write clause, basically writing to the database. So you can create a new node or relationship. For example, I can just create this particular node. This was not existed before, or I can just click on this over here, and then I can add in my name. So my node is also created. This is just a node that is I'm creating. There's no relationship which I've added, so I need to add a relationship as well in some time. Okay, finding nodes with match and where clause. This is something which you already know. Merge clause, which is to match the existing nodes and bind them, or to create new nodes and bind them. And creating a relationship. So if we have to create a relationship where we say that, okay, the person name is Sid, which we just created, and we say the movie title is this. So we are creating a relationship of watch. So I'm saying that Sid has watched Cloud Atlas. So this is added. This is relationship types, which we already discussed. And these are some advanced Cypher queries. All right, great job. Cool. I think you're all through with it. So let's go back to our slide deck. Okay, this brings us almost to the end of our session. Now, if you want to continue your graph journey with, you can do that with Graph Academy. These are free, self-paced, hands-on online training that will help you learn how to build and optimize and launch a Neo4j projects. We have two amazing certifications: Neo4j Certified Professional, Neo4j Graph Data Science Certification. That's not all. There is an amazing t-shirt to be worn as well in this too. So if you get certified, you get a t-shirt at your doorstep. Just go to graphacademy.neo4j.com, finish the courses, get yourself certified, and get your t-shirt at your doorstep. And of course, flaunt it. Send it to us on social media, some photos. Okay, meet our Neo4j ninjas. These are the master of graphs. These are people who are actively blogging around graph database. They talk about graph database Neo4j a lot in various developer conferences. So if you feel that you are a graph expert, do share it with us. We're more than happy to hear your story. For more content, more learning, these are some amazing resources that I would love to share. Notes 2022 happened last. It was a 24-hour marathon of graph content. We have added some amazing sessions and created a YouTube playlist. We have added them from beginner, intermediate, advanced as well. So feel free to use those resources as per your discretion. We'll be back with Notes 2023 in some time. We'll be opening up the call for proposals as well. make sure you watch out for these updates. Of course, stay with the community. That's our Discord handle and our discourse as well. So discourse, whichever you feel, just join in, put in your queries, connect with the community as well. Well, that's the last thing. Looking at the future, well, I can say that uh, what everywhere, what another drop today becomes like data everywhere, but none of it can think. The knowledge lakes don't make data think, but they do make it smarter. So by embedding instructions on how to understand the data with the data at scale is what I leave you with the thought to ponder upon. That's it from my side. Thank you so much for joining in for my session and have a great rest of the Google Cloud Come Today Mysuru Edition 2023. Thank you so much. Bye. See you.